Hi, this is Charlie Sakurai from Chadwick Optical, and today I'm going to talk about what do the numbers on your prescription mean. And you have a number of numbers. One is the sphere, one's the cylinder, one's the axis. Then you have a prism and a base and an add power. And all of those things are critical elements, though not everything applies to everybody. So the first thing is the sphere. And if you think of a sphere, it's exactly what the word is. It's a ball. And what's unique about a sphere is that a sphere, when in an optical sense, has a focal length. So meaning if I have a sphere, if I have a chop off of a sphere and I put light through it, all of that light is going to focus to a single point. And then how strong I make the sphere, how deep of a curve I put on the sphere will affect the focal length, whether that's shorter or longer. And ultimately, the goal of the prescription is to focus light in a way that is perfectly clear on your retina. So the sphere is one element of that, and that is the whole lens is focusing light to a single point. Now, the second number is called the cylinder. And what a cylinder is similar to how I said a sphere is a sphere. A cylinder is a cylinder. So picture a can, and instead of focusing light to a point, a cylinder focuses light to a line. So if I put light through a sphere, everything's going to focus to a single point. If I put light through a cylinder, everything is going to focus to a single line. And depending on the curve of the cylinder, the distance will be changed for the focus point of the line. So that's the cylinder. Now the axis is what angle that cylinder is held at and where you want to focus that line. So one or the other so using those two elements, what we can do for the majority of humans is use those two elements, a sphere and a cylinder, and a combination of them to focus light and offset any of the errors that are in your eye that are preventing you from getting a perfectly clear image broadcast onto your retina. So that's the sphere and the cylinder. The next thing is prism. Prism's very interesting, and it's used in a number of ways. I'll go over the typical ways that they're used. So if you picture, I know for me, this may apply to you too, if you look at some kind of line, vertical or horizontal, far away, and quickly close one eye or the other, you'll see that those images are maybe in two different locations, ever so slightly. And when you have both eyes open, you don't even notice because your brain does the extra work. Prism is for when your brain doesn't do the extra work or is having trouble doing the extra work, or doing the extra work is causing you headaches or discomfort. So that's what the prism component is it helps your two eyes work together. That's the one version of it. The other version is, what's interesting is your two eyes together work with the rest of your body to do things like maintain balance. So if you ever want to test your balance, you can stand on one foot, close your eyes, you'll realize how critical vision is to balance. Now, sometimes after brain injury, after a concussion, something like that, there will be kind of a mismatch where the eyes think the body's one place and then the body thinks it's in a different place. And when what they do with that is they do a thing called yoked prism. So what that is instead of the prism kind of bringing two disparate images into equilibrium, the yoked prism will just shift the whole world of your vision one way or the other. And that can help align the mismatch between your body and your eyes. Now, the other thing is add power. So what's add power? Is when you get older, so typically around the age of 40, your eyes kind of lose their auto zoom function that you were born with and had for your entire youth. And as an offset to that, we use an add power, and the add power allows you to, instead of the auto zoom, because the auto zoom's broken, the add power acts as kind of a manual zoom. So if you have a pair of bifocals and you want to see something up close, there's a bifocal in the bottom of the lens, and you can look up and peek through this bifocal, and then you can see things close up where before it would be blurry. Now, the add power is also just that. So if you picture the add power. The add power is a number in addition to the first number. So if I have a sphere that's, say my prescription is +1, -1 at 180, and I have an add power of 3, and I want reading glasses, the way that I would do that is I would need to take the +1 and then add 3. So a pair of reading glasses for you would be +4 -1 at 180. So that's how the add power works. And typically, an add power is set for 16 inches. So that's many moons ago, that was set up as this is what near is. And that was a time when probably before computers and before a lot of the stuff that we do. So what'll happen a lot of the time is you find that the distance is good, the near is good, but then you find yourself working at a space in between your distance prescription and your near, which is where progressive lenses are very helpful, because progressive lenses have your distance, they have your near, and then the space between is transitioning from distance to near. So whatever distance you're working at, you can find a part of the lens that will help you focus that area. So that is the numbers on the prescription, and hope that helps.